Welcome all to my talk. So the hope of this talk is to motivate you guys to take up a career in science. And I mean, most of you are postgraduate students and you have already decided to have a career in science, but still, maybe I can, provide some more perspective into what you can expect in a life here. So I would like to thank Viras for having invited me. I mean, I surely don't deserve this invitation or anything, but then given that I have certain things to share and you have certain things to listen, I guess you are there and I'm here. So I am in no way authority in on the subject. Obviously, I'm a student just like you. And I would like to add a disclaimer that unlike most of you, I'm an engineer by trade. Though I have a PhD in computer science and engineering. So computer science is a tricky kind of engineering subject in which we have a lot of science involved and also a lot of engineering involved. So most of my experiences and most of my anecdotes which I will share here in this talk would be largely motivated from my experience there. So I'll try to, go back to basic sciences as much as I can, but then, given that most of my experience is largely around computer science, it would, it will show up in my discussions. So yeah. Okay. So what is science, right? So science is the intellectual and practical activity encompassing the systematic study of the structure and behavior of physical and natural world through observation and experiment. Like I'm sure like it makes no sense to anyone, right? Even for me, for the first time I read this, like it didn't make any sense, in the sense that what I'm trying to say is like even after my PhD and even after having got finished lots of years in science and a formal education in science as such, this explanation doesn't make any sense. This is what the dictionary says, but I'm sure this is not what has motivated you to take up a career in science or to join an institute for your higher studies, right? So hopefully over the course of this talk, I would try to deconstruct this definition which has been given and try to, add as many motivational examples as to what was this journey taken by science and how did we end up with this definition, and like what is science, right? So for remaining part of my talk, I would again add a disclaimer that when I say science, science has a very strict definition of what falls into science. So for example, economics is not science, social science is not science, physics is science, maths is science, chemistry is science, biology is science. And so there are quite a few things which are not science. So for example, PhD, right? PhD stands for philosophy, doctorate in philosophy of science, but then philosophy by itself as a subject is not science. So there are certain criteria which needs to be fulfilled for something to be called science. So we will, hopefully see all that. And yeah, so I'll try to, motivate as to what science is. So let's deconstruct it. So for me, what is science, right? Science is essentially fooling around. So a scientist is a person who is essentially a kid who never grew up. So he asks all kinds of questions which are essentially, games a kid would be carrying around. For example, the questions could be something of the sort like, what would happen if I were to, place a balloon on a bed of nails? Why is that it doesn't burst? Or why is that a person who is sleeping on the bed of nails doesn't get hurt? Can I touch electricity? Is it even possible? Like, what is electricity, right? Can I blow up a room, or not blow up a room and have a big fire, as big a fire as possible? Or what is the lightning? I mean, so here what you're seeing is a Tesla bolt, which is something like 3 million volts of human generated voltage, and this is the actual ionization which happens, and you should actually experience it. You get a smell of ionization which happens in the air, and it is a really remarkable experience to have. But then the point I'm trying to make is like, scientist is essentially a person who's fooling around. He's essentially a kid who's been paid by the taxpayers to fool around, right? So what is the importance of fooling around, right? So fooling around is actually having fun. I mean, it is building your curiosity in some way. So now you're essentially moving into a territory of asking questions like how anything works or how everything works. So you are essentially a kid whose appetite for having fun is insatiable, right? As in, you always want to break things apart. You always want to, try making things, or repairing things which can't be repaired. So as a kid, I used to break apart things. Even my kids now, right? As in, they always damage things if you were to take it from a very narrow definition of what is damaging. But then they learn a lot, right? As in, when they drop a stone on something which they're not supposed to drop, it breaks. So it actually is an experiment for them, and they learn from that experiment, like, yeah, okay, things break, and there are things which don't break, and what are the things they can do and what are the things they cannot do. So the point I'm trying to make over here is that fooling around is actually a essential part of science, in which you're asking questions which at the face of it may not have any value attached to it. It may be very foolish in some sense, but then you want to know the answers to it because it enlarges the scope of your knowledge. So, for example, a very good example for this would be sports, right? A person who is involved in sports actually becomes pretty strong physically, right? But then what happens invariably is that the person is also very aware of the limitations and the strengths he or she has. So, for instance, say if I am good at running and I know that I can not run beyond 10 kilometers per hour. So, what does it mean? I can only run for 10 kilometers, and that would take me 1 hour, right? So, this knowledge of my limitations gives me a lot of perspective towards the world. So, same is the case with anything which you do, right? In your fooling around phase of your science. So, what happens is, like, what is the limit of a object, what breaks, what doesn't break, and this essentially pushes you to the boundary of knowledge, where now you are moving away from the fooling around phase, and now you are asking questions. So essentially, a scientist is someone who's asking a lot of questions. So you are a curious being. So now you are in a realm where no question is stupid. Now every stupid question has amazing answers associated with it. And not just that, I mean, the answers actually push the boundary and the realm of the realm of knowledge. So, for example, like, I remember, so the one of the best things which happened to me in my life was during class 6 or 7. So essentially, what happened is that there was this one period which there was no teacher assigned to this period. This was a non-academic period, and the teacher who was assigned for my class was a science teacher, in the sense that she would come down and not take the science classes, and we could just do whatever we like. And at some point she said, she felt that a lot of time is being wasted, and so what she said is like, I mean, you can ask me anything. So this is like, 1990s. So my house did not have cable TV, and so there was no Discovery Channel in my house. And so all the knowledge which I had was from movies, if you can call them knowledge, and from science textbooks, right? And I have a older brother who is 7.5 years older to me, so I used to always bug him to know, what is this, what is that, how does this happen, how does that happen. So now I had this avenue of knowledge, in the sense that there was a science teacher who said, you can ask me anything. Now, this was one of the best times in my life. And I actually feel that this is the time when I actually became a scientist. I mean, the rest of it, getting a PhD, was just a formalization of that process. But then the whole scientific process, the scientific thought process, and the seeds for my thoughts and my scientific temper came through that 1 year. So what essentially happened is, like, she would just maybe introduce a few things here and there, I mean, which are way beyond our scope, and now we could ask her anything. Like, so questions used to range from things like, why is the sky having a color, or why do I have to sleep 33% of my time? I mean, if you think of it, as a kid, sleeping is waste of time, right? I mean, you don't want to sleep, you want to play a lot, you want to watch a lot of TV, or you want to read books. So what, like, why is that I'm forced to sleep, right? And what happens to me when I sleep? Or is there an extraterrestrial being? I mean, is there ET? So, and something even as profound as like, why is there war, and like, is it scientific to even ask a question like, can I stop war? So I mean, just to elaborate on it, it is actually a scientific question, and it can be actually mathematically solved. Is it even possible to stop a war, and what are things? I mean, I'll be hopefully talking about it later on in the talk. So the point I'm trying to make is like, so scientist is a kid who has this constant curiosity associated with him, and who just cannot stop asking questions. So the point I'm trying to make is that in this during your course of your post graduation or your PhD or your undergraduation, like whatever you're having, the main thing which you need to learn is to ask questions. Like you should always be in this constant lookout for asking questions. So this question is not limited to what you're studying. I mean, if it is chemistry, it's not limited to chemistry. If it's maths, it's not limited to maths. It is essentially, the field is completely open to you. There is no question which is sacrosanct. There is no area which is sacrosanct. Anything can be questioned, anything can be asked. So this is the temper which you should develop. So everything else is secondary. I mean, getting a degree or getting a PhD, or so essentially what PhD is also a degree. So over there also, it's actually called the RTP in most of the institutes. It's called Research Training Program. So what happens is that they make you a researcher. So who is a researcher? A researcher is a person who knows how to ask questions. He knows how to find answers to it. So this formal process of asking questions and finding the right answer is what the formal PhD means. But then the essential ability of yours to ask questions is what is required. So this cannot happen if you do not have this curiosity and this fooling around attitude which is associated with it. So, but then, like, science is science. It's not, it's like saying, that Sachin plays cricket because it pays him a lot, or people like him playing cricket. He doesn't play cricket because of that. Like, believe me, right? Even if no one paid him so much money, he would still play cricket. I mean, there's a famous quote by a scientist in computer science where it says that it is so lucky that people haven't discovered that I'm ready to work without the money also. Otherwise, I would have died starving, because he gets a lot of money, but then even if no one had paid him, this is the work he would have done. So it is a passion. It can only happen once you start enjoying the game. So like any game, right, you have to participate in it to enjoy it. So for instance, like so my kid, my daughter, she likes to play cricket, and my son likes to play football. I mean, they are now incompatible in the sense that they don't play with each other. They would always fight over what is to be played and what is not to be played. But the point I'm trying to make is like, both of them are games, both of them are sports, but then you have to find what you enjoy. So for that to happen, you should be able to play this game of science. So what I'm trying to say is like, science is a game where you're playing with the universe itself. So if you were to think of this universe, it is essentially hiding from you. So it's a romanticized view of science would be a hide and seek game, in which the space has, the universe has actually hidden from you, and now you have to, essentially find out the universe. For instance, you can think of it as tuning your FM radio to get the signal for the song you're trying to listen. So there are, hundreds or even thousands of channels which are floating around there, and you have to find the channel which you like and the song which you enjoy. And so science is like that. So if you think of it, so E is equal to mc squared. So what is it? It's essentially a formula which, I mean, one of the most beautiful formulas which captures the relationship between energy, mass, and the fundamental constant of speed of light. So, I mean, what is it? It is essentially a mathematical equation. But if you were to look at it as a mathematical equation, and if you were to look at the theorems and the proofs associated with it, I mean, you will never enjoy it. I mean, so what I'm trying to say is like, this is the reality of the world, and this is how the world has hidden its the beauty from us. And Einstein was able to reveal this beauty by, just finding this particular equation. And it is never the equation which is beautiful. It is the message and what we found out from it. We found the relationship between mass and energy. So this ability to see things beyond what is being said, in the sense that beyond equations, I mean, that is one of the curse which science has, in the sense that the language of science is maths. And the reason we have maths is because we want to be precise and accurate about what we say and what we don't say. It is not like English, where there are 100 ways to interpret it. There are, for instance, I mean, you just have to listen to any politician speak, and he would, give you 100 ways to interpret it, based on the community which is interpreting. If it is the police which is interpreting, they would give you a particular interpretation. If it is the political base which is interpreting, they will give you a different meaning. But then max has to be precise. So that precision, with that precision, what happens is that it looks very mechanical, but then with training, you would be able to see beyond that mathematical equations and actually see the beauty of it. So for that, I mean, maths is, as I said, the language of science. So you have to master it. There's no way around it. But then once you master it, it's like, if you are to play football or cricket, it's like practicing a particular shot or practicing a particular kick to ensure that you always get it right. Once you get it right, then you don't have to think how to kick or how to hit the ball. I mean, that will happen naturally. So same is the case with maths. So once you master it, then the whole universe is playing a game with you, and you are playing the game of hide and seek with it. So E is equal to MC square is a very beautiful example of that. I mean, if you have seen how Einstein discovered it, it is amazing. Essentially, it was a stroke of inspiration. It is like, it was like a poetry, a person who's writing a poem, and how the inspiration comes. So for instance, I'm a computer science engineer, right? So I write code. So code, if a person who doesn't know how to code, for them coding is a bunch of lines and bunch of instructions. But then I'm not kidding, I'm not making it up. For me, coding is like writing a poetry. It's like writing a good code. We have debates on how the code should be structured, how it should look like, what are the names of these variables. We actually enjoy writing it. It's because we see the beauty in it. So that can only happen once you start playing this game with the universe. So the universe is constantly hiding from you, and you are constantly trying to reveal it. So same is the case with discovery of gravity. So just as an anecdote, I would like to remind that when Newton was actually a student in Trinity College when he discovered gravity. So there was this plague outbreak in London, and his college was shut, and he was in his hometown. Just like now, because of coronavirus pandemic, I mean, I guess you are at your home. So similarly, he was at his home, and he saw an apple fall. I mean, it's an apple falling. I mean, what is happening? So, but then there is something hiding behind it, right? I mean, why is this apple falling? I mean, is it the apple falling to the ground, or is it the ground moving to the apple, or is it both? So these are the kind of questions which he had, and the end result of that is the discovery of gravity. And I mean, in some sense, it was a start of a golden age of science, right? I mean, so many discoveries were made, so many things were known about the universe. I mean, the Earth is round, and the rotation around the sun, and so many other things. Where I mean, it is just amazing what happened after that, right? I mean, so this cannot happen unless you start enjoying it. So same is the case with the double helix structure of DNA. I mean, this was a phenomenal discovery. But then if you think of it again, it is hiding in plain sight, right? I mean, every living being has it, but still no one had discovered it. So only the last century that we discovered it. And once you discovered it, these discoveries actually give you new perspectives to look at things. As a result, more and more things about the universe always gets revealed. So you are more equipped to play the game. As in, it's like developing new techniques. Your pull shot in your cricket has improved, so now you are able to play bounce as well, or your kick in football has improved. So as a result, now you can take free kicks well. So it builds the confidence with which you can play the game, and also makes you enjoy the game a lot. So just as a reminder, where are you playing? You're playing at a universal scale. Universe is your playground. I mean, you're not playing, a trivial game. The, the other participant is actually universe, who's also playing very well with you. It is not being harsh to you. It is not being condescending or anything. It is always trying to inspire you. So for instance, I mean, let's see, this is the largest experiment humankind has ever made. This is, experiment by 100 countries. I mean, there's a collaboration of over 100 countries and 10,000 scientists. This the whole tunnel spans for 27 kilometers. It is 175 meters deep, and it is to find one basic particle, right? I mean, Higgs boson, if you think of it, I mean, there are many more things which they do with there, but then the scale of this experiment, I mean, what, if you think of it, I mean, even the scientists who are doing it, and even I don't know if there is any practical purpose to it. I mean, immediate purpose to it, but then in the long term, there's a lot of things which we can discover and understand from it. But then we are playing on a universal scale, right? So these are the kind of experiments or the games the scientist gets to play. So we are not trivial. We are not, I mean, I'm not being condescending, but then just to brag, we are not fixing accounts. We are not, being MBA where we are trying to sell things which need not be sold, or we are not trying to make things which need not be made. We are always in this pure pursuit of knowledge. We are knowledge in the sense that when we are trying to discover what is the reality of the universe, uh, I mean, we are always in this pursuit of a universal scale, right? I mean, we are never talking about small things. So, I mean, this was one particular experiment which was done in 1919 to verify the general theory of relativity. So, and this experiment spanned two countries, two ships, and precise. It had to be done during a total solar eclipse. And so the point I'm trying to make is, like, as a scientist, I mean, the experiment itself was spanning half a globe, right? And of course, I mean, Corona goes without mention. That, I mean, this is a true example of what is the scope of science, right? I mean, science has to come in, has to protect the world, right? We are there to defend the world also. We are there to, discover things also. So as I said, it's a game, right? So there is an inherent beauty to it. So there's a technical term, actually. It is called the aha moment. So this is the moment where you actually experience it within yourself when universe reveals some things to you. So I mean, I cannot, describe the feeling to you, but then I mean, you have to experience it. So for instance, like, one of my aha moments which I have had is, like, so there's this scientist, Ibn Haytham, I guess. So he's the father of optics. So one of the questions which he was asking is that, is the atmosphere finite? So we know that the atmosphere of Earth is finite, right? But then if you think of it, we know it. At his time, this was like medieval times. So at his time, there was no knowledge, right? I mean, atmosphere could very well extend up to sun, right? We don't know that there is a limit to it. So he made observation that, sunlight is visible even after the sun has set. And he concluded that this is only possible because of a refraction happening. And this refraction implies that there is this boundary where the atmosphere ends and the light actually entering the atmosphere, and which implies that, the atmosphere is finite, the height of atmosphere is finite. And as a result, he was even able to predict the exact measurement. And I guess it was only off by uh, 2%, I guess. I mean, it was very precise for a medieval scientist. I mean, given that he was the first scientist. So he's not just the father of optics, he's actually called the father of science as a whole, because he is the one who actually defined a scientific methodology. I mean, that's beyond the scope of this talk. But the point I'm trying to make is, like, when I actually heard that, I mean, I was I could not control the emotions which I had. I mean, it was exhilarating. I mean, the kind of experience he would have had, I can't even fathom. If the experience which I had was uncontrollable, I can't fathom the experiences he had. I mean, same is the case where, one of the courses which we are required to do in our PhD is called real analysis. So that is actually study of um, numbers, if you can call that. So it is actually the introduction to differentiation, integration, and number system. And so it's not just differentiation integration which you learned in class 12, which is way beyond that, in the sense that they're introducing a lot of concepts in it. So one of the questions which they actually were discussing is like, what is 1 plus 1? So we know it is 2. I mean, what's there to ask, right? I mean, what is 1 plus 1? But then it is not as trivial as that. I mean, we know that, one apple and one apple makes two apple, right? So, but then what is 1 plus 1? How do you define? Because maths has to be defined. It has to be precise. It just can't say that 1 apple plus 1 apple is 2 apples. So anything can be combined as 1 plus 1 and it is necessarily 2. It doesn't happen like that. So there was this one particular book called Principia Mathematica by Bertrand Russell. So if I remember my numbers correct, there were 300 plus pages just to prove 1 plus 1 is 2. So once you start seeing the complications behind it and you start appreciating the beauty behind it, I mean, that was another aha moment which I had. So this aha moment can only happen once you are able to see the beauty. So one very famous example of this aha moment is, the famous Eureka, as it is not historically verified, but then as the story goes, when he discovered buoyancy, right, he ran through the streets of Athens naked. So the actual history behind that was that the king was gifted a crown made of gold, and it was pretty beautiful. King liked it, but then king was not sure that this is pure gold, in the sense that he thought that there is something mixed in it. It's not pure gold. But then the way to verify that was to melt the crown and to ensure that it is pure gold. And he didn't want to melt it because he liked the crown. Now, Archimedes was the chief scientist, if you can call him like that, of the king, and he wanted it to be verified that this is pure gold. And now Archimedes was playing around with this question for a long time as to how do I ensure that it is pure gold or not without melting it, right? And that's when, on one particular day, he was taking a bath in the bathtub, and water got displaced when he entered the bathtub, right? This displacement of water and the connection between volume and the displacement of water, connection between volume and the density, all of this, suddenly fell into place. And now for us it is obvious as to what is buoyancy, or what is volume, and what is the connection between volume and the density, and blah blah blah. But then he was the first one to see it, right? Once you see it, and when it's like fixing a jigsaw puzzle. I mean, once I had a good fortune or a bad luck, so to say, of playing with 2000 piece jigsaw puzzle. I mean, believe me, 2000 piece jigsaw puzzle is not a child's play. This was, I mean, I thought me and my son, who is only 9 years old, we will do it. But then obviously he could not do it, and I ended up doing it, and it took me 7 days to do it. 7 days, not entire day, but few hours each day. But then the point was like, it was so large that no piece made sense, but when it fell into place, it gave you a lot of love and affection towards the puzzle itself. So same is the case with your ability to put things into place and to appreciate the beauty of it, which he was able to do, and he could not control it. Same is the case with, I mean, this is a very famous movie called The Beautiful Mind, and this is about John Nash. So John Nash is, uh, I can't say he's the father of game theory, but then he has significant contributions in game theory, and he has got a Nobel Prize for that. So game theory is a field of mathematics which models things as a game, literally as a game, in which there are participants who are playing by the rules of this game, and you're trying to find equilibrium, in the sense that when will the game settle in a win or a lose or a stalemate. So this actually, I mean, it sounds very dry and a very mathematical subject, but then this has real profound effects. So this is arguably one of the most significant contributions in mathematics in the last century. I mean, not the most important contribution, but then arguably one of the most important contributions of the last century. If you look at the repercussions it has on other fields, the trickle effect it has on the other fields. So again, as it was portrayed in the movie, he was asking the question as to what is the chance of him getting a girl for a dance. And there were, 4 or 5 girls and 4 or 5 men. And he formulated it as a game in which, participants are trying to win over a girl and the girl is trying to win over a boy to get the best girl or a best boy. Once he formulated it as a game, now he could see almost every social interaction as a game. That's where I was, alluding to when I said, can a war be stopped? So stopping a war is also, if you think of it, it can be modeled as a game. And so same is the case with auctions, which happen in which companies or entities are trying to buy and sell things, and you're trying to determine what is the ideal price to buy or sell. Same is the case with setting up, shops. Where do you want to set up shops? Or something as trivial as cutting a cake. What is the ideal way of cutting a cake so that everyone is happy? Or what is the voting system? So game theory is really profound. As the teacher who taught me game theory told, I mean, there's absolutely nothing which cannot be solved by game theory, in the sense that if you can model it as a game, there is a solution to it. So modeling a thing as a game is, so we are talking about interactions, obviously. So, so again, that was his aha moment, obviously. But then this ability to generalize things or to, abstract it out. So what I mean by abstracting it out is like once he modeled it as this mathematical game, now this framework could be applied to anything he saw. As a result, it was really elegant and beautiful. But then you need an eye to see the beauty. So just as you have to be cricketer to appreciate how good Kohli or Tendulkar is, in the sense that if you don't play cricket, you will never appreciate it. So I mean, once I was in a football museum in Brazil. So and I was only Indian, and someone asked, tour operator asked, like, so you in your country is football big? I was like, yeah, football is big, but not that big. So we have something called as cricket. They're like what is cricket? So then one of the persons in the crowd said, oh, cricket is like golf and you have a bigger bat. So it's like, that's the perspective of cricket. So now if I were to say, oh, you should have seen the pull shot which Sehwag made or Tendulkar made, I mean, they will never appreciate it. Forget about even knowing the game. There's no way they can appreciate it. So you should know the difficulty of a thing or the perfection of the thing to even see the beauty of it. So here, the beauty of Nash equilibrium or a game theory only comes when you are also in that position to see things. So in some sense, science is a place where you are able to see beauty in most of the things. So this is again infinity. So infinity is a number which I was, so infinity is not, so I'm sorry, infinity is not a number, but then, so what I'm trying to say is like, the concept of infinity and infinities, which obviously doesn't make sense to most of you, but then believe me, there are infinite infinities. So this was discovered by Cantor. So you would notice that most of the things which I say are discoveries, right? There are very few inventions which human has ever done. Most of the things are discoveries, and discoveries are actually amazing, and they reveal a lot of things to us. So yeah, so Cantor was the mathematician who discovered infinity, and he was so radical for even for the community of mathematicians that many of the people could not understand him. So if you remember, I had told that maths is the language of science, and set theory is the language of maths. And set theory was discovered by Cantor, so you can understand how big of a fundamental contribution set theory was to mathematics and by extension to science. So what I'm trying to say is that there is inherent beauty to science, and it needs a bit of training to actually see it and appreciate it. So yeah, I mean, so everything is a perspective. And once you start appreciating the beauty of it, then you move beyond the realm of learning to a realm of actually playing the game, in the sense that now you appreciate it, now you enjoy it. So yeah, so this I guess I'll just skip over the slide given the time. So yeah, so as I was saying, so science is beautiful, science is fun, yes. But then, as the famous line in the movies go, with great strength comes great responsibility. So essentially, scientists as scientists, you will be the guardians of the galaxy. So you, which we saw during the Corona time, that the whole scientific community had to, come up with all the mathematical models or the biological contributions or the chemistry for making medicines, or even the logistics of controlling people and things. Everything had to be done by scientists. So scientists were the people to whom the whole world turned to when the times were dire. So you are actually guardians of the galaxy. So it's not a small task, and it is not just a small task. I'm sorry, it's not a small task. It's a very big task, but then it is much bigger than what you think it is. So to become a scientist, right, it takes a lot of training. I mean, I remember one of the interviews of Virat Kohli, in which he was asked, "Whom do you like? Is it Messi or Ronaldo?" He didn't even hesitate for a second. He said, "I like Ronaldo." I mean, there's no second opinion on it. Messi is great; he's totally talented, but then Ronaldo is beyond this world. I'm quoting him. So what he said is that the Messi is born talented. He practices a lot, yes, but then no one can imitate him, right? I mean, he's on a different level. But Ronaldo is not like that. He is talented, yes, by many standards. He's very, very, very talented. But then he has honed his talents through practice. So he is someone who has practiced a lot to reach to a level where he is. So it's through his hard work that he has reached. So not everyone is Einstein or a Newton, but then scientific process, scientific methodology, that is something which you can achieve. And the path to it is not glamorous. It is lots of sweat, lots of training, lots of bullying, lots of failures. But then, you should have the tenacity to, have it. The path is obviously not glamorous. Though the final destination is glamorous, the path is not glamorous. So science, is a tough journey, but then it is a journey which everyone has to take if you want to reach to this zenith of, calling yourself as the guardians of the galaxy. So, so what is science, right? I mean, science is fun and all that, but then science is a serious business too. It is really a pure thing. I mean, I cannot think of anything more pure than science. It is, it's a pure pursuit of truth, right? Here, nothing matters, no one matters. In the sense that Einstein is not an authority in anything. It was his paper or his discovery which is, which is looked upon. It is not his statements are not relevant. I mean, he's famous to infamous for having, not being accepting of quantum mechanics initially. And but then no one stopped working on quantum mechanics just because Einstein said he's not interested or he's not comfortable with it. So so what I'm trying to say is that science is pure. It is beyond any individual. Science by itself has an existence. It is pure. No matter who supports it or not, it is truth, and it is undeniably unstoppable. So when I say unstoppable, so there's this very famous statement about science. So what is the difference between science and religion? So for example, if you were to say destroy all the aliens of the world and destroy all the Qurans and all the books associated with the religion, arguably you just cannot reproduce it, right? I mean, it's God's work. That's what we claim. So no human can make it. But science is unstoppable. So what he said is, like, unlike religion, you cannot destroy science. If you were to kill all the scientists, burn all the books, destroy all the discoveries, just let's go back to the Stone Ages by some, miracle. Just we destroyed everything. But still, after 2000 years or 4000 years, we'll be back at where we are. We would have discovered a wheel, we would have discovered, invented a wheel, we would have discovered fire, we would have, eventually reached to a position where, we would have reached to the same conclusions of E equal to mc square. We would have made the same computer. We would have made, everything would be the same. We would have the same building, same cements. Science is unstoppable. I mean, you just cannot stop it. And even bigger is like science is a fraternity, it is an institution. So there's this very famous statement that we are standing on the shoulders of the of giants. So all the discoveries or inventions which I make now are only possible because what Cantor did in 1900, or what Turing is the father of modern computer science. So what Turing did in 1940s. So, or what Neumann did in those times in 1940s and 50s. So it is an institutional process. Science is an institution in the sense that there is no individual who is smart or knowledgeable about anything, everything, but then the whole community of scientists, they are the knowledge of humanity. So they preserve the knowledge of humanity and they keep it constantly updated and moving forward. So we are part of that great institution or the club called science. And science is transformative, as in there is nothing as transformative or powerful as science. So I'm sure there are many ethical questions which are associated with things like a nuclear bomb or AI. But what no one can deny is that once an invention or discovery is made, the world is not the same again. I mean, it transforms the entire world at a very large scale. Same, and other thing, as I said, it is pure, it is the only reality which is there. So this is where the formal definition of science or the hard definition of science comes, in the sense that for anything to be scientific, it has to be reproducible, it has to be falsifiable, it has to be testable. So this is where one of my great objections comes, like for example, homeo. I hate homeo medicines, or I'm totally opposed to it. Or something like Ayurveda, in the sense that Ayurveda works, but then Ayurveda as a field is not scientific, is what I feel. So I'll just elaborate on that. I'm sure it is a very controversial statement to make, at least in India and Kerala. But then the point is like, so there is nothing called as allopathic medicine now. So it's called modern medicine, and it is called evidence-based medicine. So what it means is like, if you're able to give me evidence, I would accept it. So they have accepted yoga, they have accepted meditations, they have accepted massage, they have accepted lots of things from Ayurveda. I mean, they have no objections to using them or prescribing them. On the contrary, Ayurvedic doctor would never prescribe paracetamol or things like that. The same is the case with the homeo doctor. So they are very much compartmentalized in their false theories, whereas the modern medicines, they always are looking for the reality, in the sense that anything which can be empirically and experimentally validated, we accept it. If it is not validated, we don't accept it. It's as simple as that. A very good example for that would be Tai Chi. So Tai Chi is a form of exercise just like yoga, which is practiced in China. But then the basic principle or the philosophy of Tai Chi is to manage energy called Qi, which resides in your body, and they keep moving it around your body. It is a totally bogus or a non-scientific statement, but then it works in the sense that the exercise itself is very good for old people. It helps with your mobility and arthritis and many such things. And modern medicine has accepted it. Modern medicine has not accepted the Qi part of it, but has accepted the exercise part of it, of Tai Chi. So that thing of being pure and seeking reality is what enabled you to move away from your bias of not accepting traditional things, and making you more open-minded to accepting traditional things. So that, in that sense, science is very pure. So science actually enables you to think in a correct way. So in some sense, it teaches you how to think also. So just, I mean, the other side of the coin for science is the researcher, the guy who is actually building this science, right? Or who is pursuing this science. So who is a researcher? So all of you are technically researchers, be a master's student or undergraduate student or a PhD student. So you are a researcher. So a researcher has to be impassionate in the sense that he should not be biased at anything. So he should be trained to fight biases. So I'm sure this would be covered in your introduction to research course. So there are lots of biases which one has to play with. So one of them is obviously confirmation bias or hindsight bias or things like tragedy of means. So there are so many things which would come up in front of you, which you have to. So the point I'm trying to make is like, though there is this romanticized and very pure, artistic view of science, but then so science, as it's famously said about probability has a left hand and a right hand. So the left hand is very beautiful and intuitive, whereas the right hand is very rigorous and mathematical. And you have to master both of it. You should be able to see the beauty and appreciate it also, and you should have the rigor to break things apart and say which is correct and not. As I don't know the right proverb in English, but then in Hindi it is called bal ki khal khichna. It means you are splitting your hair. Yeah, splitting your hair and dissecting your hair and studying each part of it. So yeah, so you have to be impassionate about it. You have to be critical in the sense that you do not look at a theory based on who proposed it, be it your theory, be it Einstein's theory, be it from Homeo, be it from Ayurveda, be it from anywhere. You look at it with the same eye no matter what. So you are looking for falsifiability, you're looking for reproducibility, you are looking for repeatability. So this is the only thing which you're looking for. So you're very critical. And above all, you're philosophical. So philosophy is again, like, just to reiterate, the subject of philosophy itself is not scientific, but philosophy is the way of asking questions and way of thought thinking. So there are deductive reasonings and inductive reasoning. So there are many reasoning techniques and logics associated with it. So in computer science, for instance, we have an entire course on logic. And so it is not as simple as saying it is illogical or it is irrational. So or it is a paradox. So there are actually formal definitions of what they are. And essentially a PhD is someone who has mastered this art of asking and answering questions. And above all, I cannot emphasize it more. You have to be tenacious in the sense that you will fail a lot. I can say of my 100 experiments, 95 would fail. So you would fail a lot. So failing is given, but you have to be tenacious. That is in the sense that you have to keep going and you have to keep your head down and keep working on it till you make your discovery of thing can be done or cannot be done. And famously, a scientist is not an engineer. As you can see, engineering solution is using a duct tape and sticking it, but a scientific solution is very elegant. And so here, obviously, this is not correct image, but since still, he looks at the center of gravity and tries to balance it, and it's elegant. So science is beautiful, science is elegant. Engineering is just making things work. So yeah. So yeah, so this is where we are. So science is really, this is a definition which is precise, which is correct. This captures the beauty and the game and everything in it. But then, as I said, it is a dictionary meaning. So it, but then to become a scientist, now you have to have intellectual and practical. It's an intellectual and practical activity which encompasses systematic study of the structure and behavior of the physical and natural world through observations and experiments. So your ability to conduct experiments, a lot of them, your ability to observe the world all the time is only possible if you are a child who never grows up. I remember as a child how many questions I used to ask, how I used to enjoy finding answers. At that time, we didn't have internet, we didn't have Google, so it was always good. We actually used to go to libraries and read through books. So even now, encyclopedias and those kind of books are amazing books for me to flip through, just because there are so many accidental discoveries you make, in the sense that say if you're looking for a car, you might read about a ship, you might read about a plane, and before you read about cars. So many things you see, so many nice pictures you see, which I feel sadly is not very possible in this current age of YouTube and internet. You should return to books, I would say, but then yeah, so it's a Pandora box. We have opened it. There's no going back. But then yeah, so the point I'm trying to make is like that curiosity, that inquisitiveness is still there in me, and I'm enjoying it a lot. If not, I can never have a career in research. So PhD is a way of life. It is not a career. It is only possible if you enjoy it and if you play it. So for instance, Sachin always used to wake up at 4 o'clock. Waking up daily at 4 o'clock is not humanly possible if someone is paying you to do that. He did it because he enjoyed it, because he wanted to be in the field, because he wanted to play it. Those of you who have played cricket or football, you would know, right? I mean, you have, so for example, you have the ground from 4 to 5. You will be there before 4 because you want to play. I mean, no one is asking you to come on time. It's not like going for marriages or going to a class, right? I mean, you enjoy it, so you are always on time, you are always there. So that is only possible when you have the passion for it. So yeah. So yeah, as a career, I mean, science is a rewarding career in the sense that though not financially as much, but then it is a fulfilling career. So you can always go into academics. I mean, that is the obvious destination for any scientist, in the sense that you end up giving back to the society where you teach a lot, but then you also do research, or you can take up a pure research position. Currently, India is growing a lot. The central government has diversified its science budget from IITs, and there are quite a few ICERs which have come up, IISER, ICERs which have come up, and there are quite a few ISIs and national institutes, CSIR labs which are there. So where you can actually take up, research jobs itself. So you can take up a career in research labs, and obviously you can be a consultant. So science is, it's an amazing thing in the sense that once you have the thought process open and the way of asking questions open, there are very few limits to the kind of career you can take up. I mean, you are fit to take any job you like. So not just in science, but then science is the logical conclusion to that. So yeah, so again, PhD is not a degree, to reiterate, it's a way of life. It is, don't take up a PhD just because you want a degree. Believe me, you will regret it. It is not possible. For 5 years, struggling on papers and problems is not possible if you are not there for your life. I mean, it's not a career option. It's a way of life. So yeah. So if you are determined to take a PhD, I mean, this is the path to PhD. So after graduation, so you would see that I have interspersed each of it, the graduation, post-graduation, and PhD with, a job, in the sense that for you to be able to ask the right questions. So essentially in PhD, you're asking the right questions, and you're asking a lot of questions. So for you to be able to ask right questions, it is only possible if you are exposed to the real world problems. And the best way to do that is to actually take up a job and see the real world problems which are out there. And without that, your problem, the question, kind of research questions you would be asking me would tend to be very superficial and detached from reality. So yeah, and you would see that the last bullet is actually life. So after PhD, it's not job, it is life. I mean, you're going to live a life of scientist. So yeah. So I guess so that's it. So I'll be happy to take questions if any. Yeah.
I would like to ask
Hi, I'm sorry, you're not audible. Maybe you can just type the question in. I can read it.
I think Ms. Hasnat is having some network issues. I'm Zubair, head of the department in psychology at Viras.
Yeah,
Uh,
hi.
Thank you, Jithin sir. It was really a wonderful session, actually. I think our students deserve these kind of sessions. Not only chemistry students, I saw many of our students, psychology students, and most of the PG students are attending the session. I think all of them must have got, a good benefit. At least that spark you were trying to place. I hope that will
I
work
hope so.
out.
I hope so.
It's a really wonderful session. Thank you so much for such a wonderful session. I think we can just wait for if anyone have a few questions. Sorry, we missed out. I mean, there was some network error while introducing the resource person for the participants. I think Dr. Jithin is a postdoctoral research fellow at School of Computing and US Singapore. Presently, is working with Professor Mohan Kankanali in NCRIPT lab. His current research is focused on social network analysis. He also have obtained PhD from CSC department at the IIT Madras. Doing thesis, his thesis is on searching and optimization on graphs. So the participants, you may ask few questions or anything related to. You can have an interaction. I think we've got a nice resource person for the interactions. Once again, thank you, Jithin sir.
Yeah,
We'll wait for
thanks.
some questions.
Yeah, sure. Okay, so one of the questions is which will be the best option if I want to have PhD from abroad? So I guess you're asking which is the best college to do a PhD from abroad. So yeah, one thing you should know about PhD is that unlike a degree program where you need a large ecosystem, in the sense that, say, if you want, from my example, like if you want to do a master's in computer science, there are quite a few subjects which you want to learn. So you need a very, you know, a complete framework, in the sense that there should be lots of faculty from different fields of the computer science itself. But then, say, if you want to do research, what happens is like you would have a very specific aim as to what you want to do research in. So if you want to say do research in material sciences, or if you want to say do research in renewable energy or whatever it is, so there is no one good institute for that, in the sense that there is no one good institute for chemistry, I would argue. I don't know about chemistry, I'm just saying. So there is no one good institute for computer science, in the sense that if I'm ready to work on deep learning, so there's this one particular prof or group of profs who are there in this particular college. So applications to colleges are based on on the professor under whom you want to work. So PhD applications are usually not institute based; they are research group and professor based. So you will identify a list of 10 or 20 professors whom you are interested to work with, and then try to join the college which they are in. So that's how it usually works. So yeah, I mean, you should not join a college and then I mean, so it's the other way around. You choose a prof and then choose a college. Yeah. Okay. So more precisely, organic chemistry, which would be the best country, in the sense I'm having different options from different people. So I'm not a chemistry guy. Just to clarify, I'm a computer science guy. So I have no. Yeah.
If anyone is having more questions, you can ask.
And one rule of thumb you can say is that, I mean, if you have no clue about which institutes to work in, America is the best place to do research, arguably, and Europe is the best place to do research fast, in the sense that PhDs in Europe are relatively faster, but then the quality of research is generally better in US. So it's the rule of thumb, in the sense that if you are just someone keeps a gun on your head and says, decide now, you can decide based on that. So yeah. So yeah, so again, so if I were to elaborate on that answer, so what you would face in your PhD, one of the major problems you face in your PhD is like resources constrain you from the kind of questions you can ask, right? So for instance, if I were to give an example of my work, so I work in data mining. So it is essentially lots of data, and it's kind of algorithms you run on that. So my work was limited by the size of the server which I had. So in this particular case, my prof was good enough to buy a server which had 500 GB of RAM. So only because of such a server's presence, I was able to do my work easily. So just imagine your lab doesn't have that. Okay? So then you would be required to share such a server with a group of say 10 or 20 or even 30 people. So your work would be, much slower, obviously. So having access to those resources is very important. So in Indian institutes arguably always are lacking in fund and always are lacking in equipment. So there's this one very bad example of, my master's was from IISc. So I remember a particular case of a student. I mean, I haven't personally met her, but this is a story which is famous in IISc. So essentially what happened is like, because of Pokhran test, many things were banned by America, as in many things could not be exported to America. As a result, what happened is like her whole PhD's work of 4 years got wasted, because the lab which needed to be set up to conduct the experiment could not be set up. So similar is the case with things like a nuclear material which is required for, say, even something as trivial as a biology experiment. In India, everything is supplied only by BARC, BARC. As a result, there's this very big bottleneck that everyone has to apply to BARC, and then it has to come down to, Bangalore or wherever it is going, which has lots of clerical and administrative delay. So these kind of things are totally removed in Europe. I mean, there's nothing like that. Everything is seamless. And in America, it is there are other problems, but then similar problems don't exist. So these are kind of questions you may want to ask before you join a lab. Is the lab very well funded? What is the access to resources and things like that? For biology, for instance, Europe is supposed to be amazing. I mean, again, these are all secondhand information. I'm not working in biology and chemistry, so yeah, I'm not authority on that. I guess everyone's very charged up, so there are no questions. Yeah. Yeah, so just to, maybe to fill in the time, I would say that so one of the very good things which I feel I have is that I always enjoyed asking a lot of questions. So I was one of the tallest guys in my class, but then even then I would always sit in the front bench. So all my teachers know me, in the sense that I always interact with them, I always interrupt them, I always discuss with them. So it was one of the amazing experiences to have. So college life or school life, I mean, there's nothing better than that. I mean, I graduated only recently, but then I really miss it, in the sense that there's no limit to the scope of things you can do, and the kind of no responsibilities associated with you. You are purely in this pursuit of knowledge, and knowing things and excitement is only possible as a student. So I would really urge all of you to enjoy your time that you are having now. You know, this is the last few years you have in your life where you can enjoy this. So do enjoy it as much as you can. So yeah. So I guess we can call it a day. Not a day, I mean. If there are no further questions.
Sir, there is one more question by Swarna. Could you please?
Oh, okay. Well, you mean elaborate on my research? So, so I work on graphs. So graph is essentially a network. A network, as in you can think of a road network or a social network, or you know, a molecule is also a network if you think of it like that. So in maths, networks are actually called graphs. So that's why it is called graph theory in mathematics. So I work on graph mining. So what it means is, like, say if you have a large graph, like a social network graph, say Facebook. So there are 1 billion nodes and there are edges between them. So edges in this particular case would be friendship network, right? So once you have that, so there are lots of questions you can ask about the network, in the sense that how strong the network is, or say a rumor spreading, right? Say I start a rumor that there is a bomb here, and so someone else retweets it, or you know, shares it again. So again, it keeps spreading. So this is called a rumor spread or influence spread. So how do you model it? How do you control it? Or how can you even control it? Can you mitigate it? So these are all questions which come in graph mining. So I work on such problems, and so currently one of the projects which I work on is the Twitter network of elections. So one of the elections we looked at is Bihar election. We are also looking at West Bengal elections and stuff. So yeah, so these are all research work, in the sense that none of it is for any actionable item, in the sense that we haven't even published the paper on Bihar yet. We'll be publishing only after the Bihar election is over. So as in now, and similarly, West Bengal is only after the West Bengal election is over. So nothing is political, if I were to say. It is just a graph question which I have. So yeah, so those are kinds of questions which we ask and try to address. So it's it's more mathematical, and so computer science is actually a hybrid of maths and physics, and yeah, maths and physics, I would say. Yeah. So yeah. So thanks for your time, and thanks for attending, I guess.
Thank you, sir. Actually, I think our institute, Vadihuda Institute of Research and Advanced Studies, is actually focusing on research and its
Thank you.
orientation. So I think you are a right resource person for us. You can expect future, invitations from our institute.
Okay.
Fine. So I leave the session upon to Miss Anaga, who is moderating the session. Anaga, you may take over.